All right, welcome back to Physical Science. Again, I'm Mr. Harriman, and we are finishing up on our last part of our binary compound nomenclature. Again, nomenclature, that fancy word just for naming system. Okay? So now the last step is we're going to be looking at how to create a chemical formula from a chemical name. So chemical name to chemical formula. All right, so again, make sure you have your handy dandy periodic table cheat sheet. Again, you can download that from Google Classroom, or you may download that or get it in my classroom, okay? All right, so now, basically, we look at, again, our element, we look at the first element. Now this way is a little bit trickier than the other way, but again, we have to figure out if we have a metal, all right? The first element, if it is a metal, okay, then we have an ionic bond. If it's not a metal, then we have covalent. And again, that's 99% true. There are some exceptions here and there, but again, I'm not doing those in freshman physical science, okay? So anyways, we look at the words. Let's look at this one first. That'll be your practice one. Okay, we have pentacarbon dicoxide. So looking at this, all right, we have to figure out what element we might have right here. So if you're looking at this whole word, pentacarbon, what element do you kind of see? And hopefully you recognize you have carbon. Well, carbon on the periodic table, again, is to the right of the stair-step line, the metalloids, and therefore carbon is a non-metal. So this is a no metal name here. No metal. We're on the right side, the covalent side. Okay? So again, we're now creating this time a chemical formula. So let's go through our steps. Only 2 steps. First step says symbol. All right. So we look at our periodic table, and we see that the pentacarbon, the symbol for carbon is C. Pretty easy so far. Dicoxide, now again, that's kind of tricky because we have a prefix, we have an I, so we got to figure out what the root of the word is. Again, in this case, and hopefully from repetition you'll get it, this element, the ox, is talking about oxygen, all right? And the symbol for oxygen is O. So we have CO so far. Okay? Pretty straightforward. Next step, prefix equals the number of atoms as subscript. So the prefix means the number of atoms as a subscript. Well, penta, if we look at our handy dandy cheat sheet, is 5. That means we have 5 carbons. Dec, now if you look here, there's deca. Again, a lot of times we drop a vowel. We don't have 2 vowels next to each other. You will not have to do that. If you have deca, it's perfectly fine. Okay? It's just a way they do it. All right? So dec, oxide, dec is 10. And we are done. So pentacarbon dicoxide is C5O10. By the way, disclaimer, this might not be a real chemical in nature. I just threw this up to practice the naming system, okay? So please don't be like, there's no such thing as this. There might not be, I have no clue. I didn't do the actual Lewis dot structure and figure it out. Yep. Now listen, a lot of freshmen make this mistake as they look at this, they're like, oh, 5 and 10, I can reduce. Divide them both by 5, and that becomes 1, that becomes 2, and this is CO2. No, that's wrong. CO2 is carbon dioxide, all right? The air you breathe out, okay? Or chunk of the air we breathe out, all right? You cannot reduce when we're doing the covalent side. You have to keep this like this. This is if this was a real chemical, which it may be, I don't know, that's how it's going to be in nature, with 5 carbons and 10 oxygens attached to each other, all right? Doing whatever they do, if that's real. So go ahead. I want you to pause the video, and I want you to try this chemical name and see if you can create the chemical formula from it. All right, welcome back. All right, again, I look like an idiot because you didn't pause it, but here we go. Let's do this one. So first things first, again, everything we do with the nomenclature, whether we're doing the formulas or names, look at the first element. Is it a metal? If it's a metal, it's ionic. Left side. If it's a non-metal, right side. And again, like I said, that trick works 99% of the time. A few exceptions, but we're not doing those exceptions in this class. Let's just keep it simple. All right? So, try phosphorus. That sounds a lot like phosphorus. And you'd be right. Phosphorus, to the right of the metalloids, non-metal. So because it's a non-metal, We do the no metal side. All right, so we're trying to find a chemical formula, so we use chemical formulas. First step, symbol. So our symbol for phosphorus, look at the periodic table, P. Now, non-chloride. Goofy looking word, but again, find the root of it. Kind of get rid of the prefix, get rid of the I, and we have chlor. Well, what does chlor sound like? Chlorine. And if you look at the periodic table, chlorine is Cl, lowercase l. That's step one, PCl. Step two says prefix is the number of atoms on that element as a subscript. Tri, our handy dandy cheat sheet, 3. Chlorine, nana, 9. Or nona, whatever they say it is. P3Cl9. Again, I don't know if that's a real chemical. I just made that up to show how to use the naming system. Okay? If you have any questions on this, just email me or come into my classroom. Again, no reducing, no crisscross applesauce. That's on the ionic side.